be really formal, then you have to be really formal. Otherwise, like some say, okay, no shorts, no slipper, then just follow. Okay. Okay, I think we better start now because I feel quite dizzy. So let me cover the lecture, then let you go. Okay, now you see here, these are the, if you don't hear my voice clearly, you let me know. Okay, so if you don't understand anything, also just ask the question in the chat, or you can raise your hand or just unmute and ask. Okay, okay. To understand various techniques of requirement. So where are we now? Where are we now? We are here. So we already done with elicitation, we done with evaluation, we already cover the specification and documentation. So finally we are at quality assurance technique. So in the quality assurance technique, what are the important things you need to know? Okay, this is another very important topic that will be there for sure in final exam. Okay, requirement inspection and review. How to validate requirement. Sorry, how to validate requirement. So the validation and verification of requirements are done through inspection and review. So we will go through the inspection and review. Then we will also learn what is the importance of having prototype during during the validation. So how do we actually, prototyping is another way to validate verify requirement. Can be used Prototyping can be used in validation and verification. Okay, what is model validation and model verification? And finally, acceptance test. Okay, so how can we relate acceptance test or testing with this chapter, validation and verification? So basically, we are here. Quality assurance is validation and verification. So by right, there are only four phases in requirement engineering. So the last phase is actually this one, validation and verification. Okay. Okay. How many of you know what's the difference between validation and verification? You read this, see whether you guys can understand or not. Validation, okay, adequacy of requirement document items, okay, versus real needs. Yeah, this is the sentence that I always give my students. Build the right system, build the software right. Yeah, correct. But do you really know what's the difference or not? Okay, validation, verification. If you have taken software engineering tutorial class with me, then I guess I have explained to you. Okay, completeness, consistency, and NADI. Okay, so what is verification? Verification, you don't need a source to check. Okay, what is validation? You need a source to check. For example, you enter username and password in a system. Then the system check your username and password and allow you to go in if the username and password correct. Okay, this is validation or verification? Tell me. Anyone? You enter password, username in a system to log in. The system checks your password and username, then let you go in. Like meaning allow you, because your login successful or unsuccessful, it depends on the username and password. So that is validation or verification. Okay, give me your opinion. I want to see how many of you can guess correctly. How many of you are not really sure? Oh, sorry, I'm taking this medicine. So, if that's why my voice sounds a little different. Okay, so now, oh, all say verification, not even one say validation. Okay, let me make it clear to you. Okay, now you have a source. Yeah, I wonder how come all say verification. Now you have a source here. This is your source. You know what is source, right? Where the information, the original source, where the information come from. not the source. So when you first time register, you create your password, correct or not? First time you register with the system, you create your password. Then every time when you log in, you try to enter your password which is similar to your source, correct or not? So when you log in, you're using the username password which you have already registered. So if this two same, the checking will be done by referring back to the source. If it is similar to the source, it is known as validation, not verification. Okay, this is validation. Anything that you have something to refer back, to check, to compare, that is validation. That cannot be verification. You understand or not? So if you say the system verifying something, then you have to see whether are you doing this process. If you're doing this process, then correct. Verification. What validation? Okay, what is verification? Verification. Okay, now we go to ATM. ATM got both, ATM. Now let's say we have ATM system, right? Okay, ATM. You need to enter pin, 6-digit pin. Correct or not? Okay, when you try to enter one, two, let's say three, four, five, or you go and enter a letter, character, alphabet, which is not digit. Okay, system first will check whether you have entered 6-digit or not. 6-digit, all 6-digit or not. Okay, the system will check because we know ATM password, no alphabet, no symbol, only digit. No need to go and check anywhere. Every ATM system will have 6-digit pin. So first you enter the 6-digit pin. First the system will check. Have you entered all the 6-digit or not? Have you entered digit, 6-digit or any other character? Second, have enough 6-digit or not? First, of course, first 6-digit or not? All the 6 characters now all digit or not? So this kind of checking is actually to check on the correctness, correct or not? Check whether all the what input is based on the what required structure, required format. Yes or no? That is verification. That is verification. After the system checks, okay, this user already entered 6 pin, okay, 6-digit pin, all digit, ngam 6, okay, enough. Then it will compare with the source. When comparing with the source is actually validation. Comparing with the, because you already last time save your 6-digit pin what when you register an account. So first it will check whether it is up to the format, up to the structure or not. That is verification. After checking whether it is up to the format, up to the structure, it will go to the source and check whether similar or not. The similarity, comparing the source with your input is validation. Checking on the format and structure is actually verification. How many of you can understand? Or still don't understand? How many of you still don't understand? Raise your hand. I will find another way to explain. Yeah, because I always see student use the wrong word. Student always say, it verifies my password. That's already wrong. You understand or not? Okay, checking on the format or structure which you don't need the source is actually verification. Okay, like we know 6-digit what pin is always all digit and 6 characters length. So checking on that is verification. After checking on that, if chukup 6, then it will try to compare with the what do you call that? Compare with the saved password. That is validation. So verification and validation. Okay, can you understand? Okay, now we continue with our validation verification. Okay, now you read this, you can understand, I think. Okay, somehow I'll repeat this again for model validation and verification. So finds as many of this as possible in RD. So it will see whether your adequacy of RD items versus the real needs. This who gives you the real needs? Okay, who can tell me? Who knows the real requirement? Okay, GHE, right? Okay, you say so like we require the user to fill in a form. So in the form, what are you checking now? You just explain that fill up the form. You didn't tell me what kind of checking you are doing now. Are you checking on all the fields have been entered? Then that is verification. If you check whether the value entered is correct, okay, then that is validation. Check for what null values, that is verification. Check for format like email address, I got @ symbol or not, that is verification. If you check whether the email address is similar to the registered email address, that is validation. You understand or not? Okay. Now let's proceed with this. Okay. So now you see. Okay. I asked a question, right? Who knows the requirement? Who knows your requirement, the correct requirement? You are now a developer. Let's say you are working on a project. Who knows what supposed to be there in the system? Who knows about the requirement? Requirement engineer, are you sure? Then you know everything. So whatever you say is correct, 100% confirm. You continue. Okay, your elicitation, evaluation, specification. Then come to here, right? Who can tell you that your requirements are exactly what do you call that as needed, expected? Who can tell you? Yeah, client, exactly. So client is actually the source. Client is the source. So after you've done a lot of activities to collect the requirement, to evaluate the requirement, to specify the requirement, actually all this come from whom? All come from the client. You find a way to understand what they want, because you know what, sometimes they know what they want, of course they know what they want, but they don't know how to express. So that's why we have a lot of issues normally when getting the requirement. So we try to analyze all the requirement, and finally we document. Then we need to check whether this is what exactly they want. So that process is validation. And that process is validation. So what we do, we go back to client. We go back to the client. We ask them, if this is what you want, final checking done by them. So that's why you see assignment, I don't ask you to do validation one. Your assignment yesterday, right? Today was the date. Today Thursday. When you submitted, oh no, Monday, sorry. Oh, I see, guys. So don't know, 3 days fly so fast. Okay. So here, right? Elicitation, evaluation, and also specification and documentation. You guys did for your assignment, right? You didn't do the validation and verification. You are not required to do validation and verification. So you need to just conduct these three. So the validation, verification, you need to do with your client. Okay, you understand or not? So that's why we tutor, we will act like the client. Why? Because we ask you to find a real organization, an existing organization. So we also, when you guys propose a title, we also try to understand that organization's problem. Then we see whether the requirements that you have come are analyzed, appropriate or not, valid or not. Okay, so that's why we help you to validate and verify the requirements. So we act, or we play the role of client here. Okay. So that's the thing. Okay, so now we continue with our what do you call that next slide. Okay, quality assurance and requirement engineering time. So of course, after what do you call that, your requirement document, go through the validation and verification, right? There are few output. Okay, what are they? First of all, your requirement document will be known as, first of all, your requirement document will be known as consolidated requirement document, meaning after the requirement document go through SRS, the SRS go through the validation and verification, it is checked, it is finalized, we call it as consolidated requirement document. So meaning your customer's client agree with what is written in the document. So meaning your requirements are finalized, okay? With this, right, you can use it to sign the contract with your client. Okay, so you have to wait until your consolidated requirement document is produced. Once you have your consolidated requirement document, you can sign the contract. If you are lucky enough, you can get the contract. You cannot promise after you're done with the consolidation, the project goes to you. Sometimes a company, like big companies, usually invite a few vendors, and then they only what do you call that, agree. They only agree to sign the contract after going through the document. Maybe they go for the best quotation, the cheapest, or they go for the best quality. So it depends on the client. We cannot blame them. Okay. So usually after you're done with the requirement document, okay, after validation and verification, project contract can be produced if you manage to get the project. If you manage to get the project, then you can start as a project manager. You will start your development plan. All this only done after the consolidated requirement document is produced. So that's why after validation, verification only can get all this document. So the development plan is only after the requirement document is validated and verified. And lastly, when your requirement document is finalized and the project is confirmed, you can start preparing the acceptance test data and prototype. Okay, what prototype is this? One later, but acceptance test data is for testing. Obviously, your testing is based on your requirement document. We don't prepare the test cases, test plan based on the code. We never do that. Okay, it's not a proper testing. We always prepare the test plan, test cases based on our requirement document. So we have what is our objective? We have to fulfill all the requirements stated in the requirement document. So the testing will be done based on the requirement document. So in between, your designer and your developer will prepare the design and will convert to code, right? Once the code is ready, you need to map back to your requirement. See whether the source code is actually doing what exactly stated in the requirement or not. If yes, then the code is fine. If it's not, then the code is erroneous. Okay, so you have to do something to fix it. So that's how testing is conducted. Testing always test case, test data, everything come from requirement document. So remember, acceptance test data come from requirement document. Okay, so all this are produced after the validation and verification. Okay, now we continue. Okay, first we're going to look at the inspection and review. Okay, for your information, okay, we will ask selected people to inspect our requirement document. Obviously, they are from the client side. Okay, we will have a lot of meeting, just same like elicitation, but this one, it will be slightly more formal. And this one, the purpose is validate and verify the requirement document. So what usually we do, we will conduct walkthrough. Okay, what is walkthrough? Is like less formal. Okay, if more structured, then it will be more like review meeting. Okay, some people conduct like walkthrough, some will do like very formal review meeting. So both also considered as validation, verification. So internal inspection by project members. So walkthrough, we will invite our members, our project team members. Okay, then go through the document either individual or together. Okay, that is to check whether whatever stated in the document is exactly what are we going to develop. Okay, and also fulfill the customers or clients requirement. If you do more structured, you invite external reviewer, well prepared meeting, and you conduct proper inspection. At the end, you will even produce the report. This one just go through within our team members. Okay, so I can show you the steps. These are the steps. Okay, so a structured inspection will go through 4 steps. Okay, the first step, you have to do the planning. You have to plan for your inspection. Okay, determine who will be the people taking part, who are the reviewers. Like in TAR, right, exam paper will go through almost the same procedure. We have 5 different moderation, 5 levels of moderation and review. Total 6 actually. Okay, the last review will be done by external reviewer from other university. Okay, so inspection planning, first when you plan the scope. Okay, what will be validated? Because there are when there is a document, right, there are so many things can be validated. So what is your focus? What is your concern? Which component will be validated or verified in this meeting? So you need to identify the scope, who will be involved. You need to identify the people, the timing, how long will be spent, and then the report format. All this will be in the inspection planning. After plan, now we will individual review. We will make a copy of every SRS, and then we will distribute to all the reviewers involved. Okay, why are we what letting every individual to go for individual reviewing first? Because we don't want each reviewer influence the others. Okay, we let them to find whatever they find. If for them, if it is not appropriate, they can just identify it as a problem. We can later discuss when we have a meeting. So we will let them to go for individual meeting. Finally, when all gather together, okay, we will what do you call it, discuss, sit together and discuss defect evaluation meeting. So this defect evaluation meeting is also known as review meeting. Okay, mainly in the review meeting, we will discuss all the problems identified by each reviewer. So each of the reviewer, when they point out, okay, this is a mistake, right? Then everyone, the others will also share their opinion. And then they will discuss and confirm whether it is a problem or it is nothing. Okay, fine. Can just leave it. So no one influence anyone. So that's the reason they do individual first. Okay. And finally, what RD consolidation is prepare the report. And then based on the report, the requirement document will be written, meaning the requirement document will be like corrected. Okay, corrected. Okay, now free mode. What is free mode? Directly discuss and find out what is wrong. During the individual meeting, directly go through the document and find out what is wrong. You read yourself, you go through, you just point out the mistake. Or else individual meeting, you will be given the requirement document together with a checklist. Okay, what are the things you need to check? So you tick each of the component in the checklist until you cover all the components in the checklist. So either you do yourself, you're free to check whatever you want, or second, you'll be given a checklist. Third, process based. So everyone has a role. For example, you check the grammar, I check the format. Okay, let her to check on the technical syntax and semantics. So we have like everyone will be checking on each of the component. So that we have different type of what do you call that, individual review. Okay, let's go on with the next one. Okay, inspection guideline. Quickly, I go through this guideline. Okay, there are you can have informative, accurate, and constructive. Okay, what is informative? Of course, we must have all the information given. Accurate, constructive means everything will be improved and update, and then we come up with a better version. Okay, during the meeting. Inspectors should be independent from RD authors. Yeah, don't select anyone who write the requirement to become the what do you call that, reviewer. Cannot, like tester, right? Same. Whoever prepare the code cannot be the tester. So if like your final year project, you guys write your code and then you become the tester. It's not a good one. Okay. Usually the what developers and the tester must be independent. They cannot be the same team. Oh, anyone, the same person do the do both job. Cannot. Same here. Whoever prepare the requirement, whoever write the requirement cannot be the reviewer. Don't. Okay. Okay, it's a guideline. So if you follow this, you will conduct the what do you call that? Conduct the inspection in a proper way. Okay. Representative of all stakeholders, different background. Yeah, try to cover different roles, different background to check on the requirement document. That will be very helpful for you to find the defect. Inspection should come not too soon, not too late. Yeah, the right time to conduct the inspection. More focus required on critical part. Very important requirement. You need more people. What review activities on that part. Okay. Okay. Now the checklist. I told you, right? We got free mode. Free mode. We have nothing to show you. You just check on. It depends on the reviewer. If you give me something and ask me to check, right? I check on my own way, right? That is free mode. The second one is inspection checklist. So the one you have defect driven, quality specific, domain specific checklist. You have language based checklist. These are few example, not all. Few example of checklist that can be used. Okay, let me show you the first one. Defect driven. So in defect driven, right, what kind of defect will be checked? Okay, omission. So what is omission? Hidden, the requirements are hidden. So meaning assumption or requirement hidden, anything hidden in the document, you can say, okay, for example, something is not given. When I check, I find some values are missing. You have explained something, but I don't know what caused you to write this. So hidden. So that can be omission. Contradiction, we have done one set, conflict management. That is an example. Ambiguous, not clear. Inadequacy means like not sufficient, not adequate, not proper. Okay. Mm, okay, unmeasurability is like non-functional requirement. When you say, I got give you example, right? The availability, the system should available all the time. The system should perform as fast as possible. The system must be user friendly. All this kind of requirement shouldn't be there. Unmeasurable. Okay. Noises other than requirement. You contain something which is not relevant, not needed. Some like unwanted information. So that is considered as noises. You remove. Over specification also not allowed. Sometimes you specify so over until what do you call that? You are restricting the design and development team. No need. No such thing needed. You don't have to mention about how to implement. Okay, that's design and development team's job. Okay, and feasibility. Sometimes the requirement is like so advanced where there's no way for you to implement. It's not feasible. There's no way for you to implement or what make it work. Okay, so for example, you propose an algorithm which is no way for you to do. Maybe in our country or anywhere you can't find such device or such sensor to implement the project. So it's not realistic. So that one is unfeasible. Yeah, unintelligibility is not intelligent enough. Okay, remorse, deep regret or guilt. Okay, for example, the requirement can affect others. Okay, like your requirement can affect others or can what negatively give impact to others. Then it is considered remorse. You shouldn't have such requirement in your document. Okay, poor structuring, you all know, right? I don't have to explain. Opacity is not what you call it, not transparent enough. Okay, so not clear enough, not transparent enough. Okay, and yeah, poor modifiability, not modifiable, not maintainable. Okay. Okay, now let's go to the next one, quality specific requirement. What checklist? Check on the quality. What are the quality aspect we can check? Just now defect, what are the type of defect? This is just an example taken from a requirement engineering book. Okay, this one taken from a very popular author requirement engineering book. Okay, so this is an example of what do you call that defect checklist. Then quality specific checklist, all the quality aspect. Okay, quality aspect. Then we have domain specific, we have one by one. Okay, so for the quality, let me go through quickly. Any unspecified response to out of range value. Okay, for example, like you know what is out of range, right? For example, let's say you explain, okay, for the system, right, there are 5 atoms. Okay, you explain, okay, what happened if 5 atoms, so you only discuss about that range. If you didn't explain what happened if it's more than 5, so you don't explain what happened when they don't follow the range. That is actually quality. Unspecified, like error handling. Okay, unspecified response to receiving expected input value, too early, too late, or never. So you don't only look at the positive flow. What happened if the user don't follow the positive flow? Okay, if they go out of the flow, what happened? That is basically quality. Okay, redundancy. Okay, repeating the same thing. Any recovery operation, when something goes wrong, for example, like reset password, I always tell you, right? Okay, you have a login function, then I'm very sure system should have reset recover password. Any output producible faster than it can be consumed. Any input same unused by the software controller. So if you have in your requirement, you have like explain about what a few input, then you notice one or two input are not used at all throughout the project, throughout the requirement document, and then unused. Okay, same like in a program, you create a variable, you create like 5 6 variables in the beginning, but after checking the whole program, some of the variables are not used. That comes under quality problem. Okay, does every state sequence from hazardous state lead to a low risk state? Yeah. So these are the example, and then consistency check. Okay, what you mentioned in the first page, second page, until the end, all must be consistent. So like I told you, right? You say, okay, optional requirement. I have 5 options here. I'm going to just choose 2 options. So your functional requirement should also implement the 2 functions, or the 2 options. The rest of the 3 options shouldn't be there in your functional requirement, because you conduct this optional requirement saying that you're going to choose only 2 options to be implemented. So it must be consistent with your work. Okay, so that's what consistency. Wait, where am I? Okay, this one done. Okay, now, yeah, domain specific. We don't have example here because domain got a lot of domain. Like medical means they have their own. If you go for agriculture, different, education, different. So different domain, we have different checklists. Okay, so it depends on the domain. What domain are you doing, and what system are you developing? So domain, I don't have any example here. Okay, you can search for any specific domain. If you want to see, you can just check. Okay, domain specific checklist for validation and verifying requirement. You can find out more. So sorry. Uh, I took a pause. Okay, next, continue. Now language based checklist. So you check on the language. Okay, so specialized defect driven checklist to specific language construct. Okay, so let's have a look. These are examples of language specific checklists. Okay, so now is this statement identifier used consistently throughout the RD? For example, you introduce a new identifier. Like this morning when I, what do you call that? I conducted a presentation among students, right? Okay, just for sharing. I'm not talking about anyone, just sharing. So I noticed some of the students have used, okay, very consistent, their work were very consistent, but some students, they have used words like sign up and then log in, and then they used sign out. They don't come in a pair. What? Okay, log in and then sign out, cannot. Log in, log out, sign in, sign out. Correct or not? That is example of identifier that you have identifier that you are planning to use, right? Must be consistent throughout the. Okay, another example. Let's say you say somewhere in the document you're going to allow the user to register an account, but somewhere else you mention sign up. Register account and sign up same meaning, but when you write a document, you have to make sure the document, okay, is consistent, okay, throughout the whatever terms that you introduce, right? They have to be consistent throughout the document. Okay, so one place sign up, one place register, okay, one place login, one place sign in, cannot. That is not consistent. Okay, does the indicated type of statement correctly refer to a requirement, assumption, domain, property, or definition? Also same. Okay, then if is the fit criterion defined in the term of measurable quantities and measurement protocols? Yeah, is this one, example. Sorry. I can give you example. Okay, sometimes when performance, right, you guys are. That's why I always tell you, go and research first. Don't simply write the requirement. So sometimes you write, okay, the system, what do you call that? Output should be displayed within 0.0002 second. Is it what do you call that? Is it relevant? 0.0002 second. It is possible for the system to respond within that little time. So you cannot simply state a value which is not. Okay, so all those things comes under language specific. Okay, then is this rational consistent with the stated system objective? Okay, again, now back to consistency. Mostly when I say language, right, you use the words, the identifier, the terms, all this must be consistent throughout the document. Okay. Okay, any questions so far? There are four types of checklists we have covered. Okay, if you ask me, checklist can come out in exam or not? Yeah, got come out before. For your information, it got come out before. I can also share the question that got come out before. Okay, discuss. What do you call that? Wait, where's the yeah, here. Okay, okay. Discuss defect-driven checklist. Okay, that prepared during inspection with examples, something like that. So got come out before. Okay, or explain defect-driven checklist with 5 examples. So you have to at least remember 5 of this. That is an example I got come out before. Okay, just to let you know. Okay. Okay. Any question? So here are a few more examples on language specific. Okay, yeah, domain. I don't ask in exam because domain, like there are so many different domain. So if any specific domain, because a different domain, obviously different type of checking. We don't have the same checklist for all the domain. Different domain, different. Like education, we have different the way of writing requirement, the terms, everything different for education compared to medical. Same thing goes to other fields. Okay, so like business different, so different domain different, so we don't really ask what domain. Yeah, we don't ask example for domain, don't worry. Okay. No, I just gave you example of question which got come out before. So I'm not saying you have to remember all, but at least understand and can remember a few of them. Then good. In case come out, at least you know what are the example. Okay, not necessary to memorize 5, but at least understand. All this comes under defect. Okay. What is under language? Okay, what is under quality? That's all. Okay. Okay. Now continue with the next topic. So you see, language specific checklist. Okay, okay. Here you can see check on formal specification. Example, I think this one also similar to what I was explaining just now. Always remember for the language specific checklist, you can use what the use of decision table will be helpful. Okay, because sometimes you explain something in the language, but it's very difficult to understand. For example, the combination of different condition, right? What will be the output? Okay, when this and this true, when this and this true, when this and this and this true, something like that. So very difficult to express using natural language. So we can always use a table to assist. Okay, a table to assist, such as decision table, a diagram like decision tree. Okay, so that's what here they are trying to say. Okay, so now move on. Okay, what is good about review? What is bad about review? So, what is the strength of review and inspection? What is the limitation, or what are limitations of strength? What do you call that? Review and inspection. Okay, experience to even more effective than code inspection. There's one code inspection usually agile. They used to do what code inspection during agile. It is proven that requirement document inspection is more effective than code inspection. So you don't wait until the coding time, okay, to check on the work. You check now requirement. Now you can make sure the code got no issue later. Okay, so that's why they say this inspection is more what do you call that? More effective compared to code inspection. Okay, wide applicability. Yeah, any defect type, any specific format, everything can be checked and validated, verified. Okay, so it's like wide application. Okay, And then burden cost of inspection, yeah, always, right, when you spend time, you need to find people, you need to spend time, you need to find the resources, always costly and time consuming. Okay. And then the last one is the best point: no guarantee of not missing important defect. At the end, you cannot promise you have found all the mistake, all the defect. You can't promise. There's no, like, one measurement, or like one way to detect, to guarantee that there's no defect after the review or after the inspection. No such thing. Okay, like my final exam also same. 1 year, right? That should, I've never made mistake before. But one of the semester in this 8 years in TA, because in other universities I've never made mistake. In TA also I always make sure my exam paper no mistake. After went through 5 or 6 review, right? Every time we prepare exam paper, right? There will be some there will be 5 or 6 review process. Okay, different parties, starting from low, like, first I prepare the paper. There will be someone in the role of senior lecturer from my department, from my field, will review the paper, knowledgeable in my area. Okay, will review the paper. Then will be AD, then will be DD, then will be dean, then will be external examiner. So there will be a lot of review, lot of review stages. No one found the mistake. No one found the mistake. That, what I do, always when I prepare a paper, right, I will start, because I lazy to format, structure the question. So I always take the last year's paper, then I edit, I change everything. So but then the numbering, the structure will be there, right? So I don't have to worry about the structure. So I have that habit. So what happened, when I tried to modify the question, I forgot to modify the scenario title. So the title appeared to be wrong, last semester's title. Okay, and one of the student asked, raised hand and asked, Miss, is this the title? That was the defect found in one of the semester. I think a few years back, 2 years back, I think. Since then, I've been more careful. So even though reviewed by so many people, still the defect was there. The problem, the error was there. That is a good example. No guarantee of not missing defect. Okay. Worst part, that year, I think all the branches, not all, but I think 3 branches, is it, taken the paper. So I got called from everywhere. Very bad experience. Okay, so now continue. Okay, now we're going to step into prototyping. Okay, what is prototyping? Okay, who can tell me what are the 2 types of prototyping? You have, wait, domain will like ask for explanation. Yeah, just explain. If I ask just generally, for example, okay, what are the different type of what do you call that, checklist that can be created for inspection process? Then you can say, okay, domain, what defect, okay, quality. So then the question will ask on the domain. But example, since I don't cover in my syllabus, because I cannot just discuss 1 or 2 domain. There are, like, thousands of domain out there. So just remember, the domain, they have their own checklist. Okay, like medical means, medical also got a lot of area, a lot of fields in medical. So it depends on what kind of system are you developing. Are you creating a healthcare management system? Are you developing a healthcare, for medical devices? Depends. So different domain, different type of checklist. That's why there's no any example given here. Okay. Okay, yeah. No very detailed one. So okay, now I continue with the prototyping. Before I start, right, can anyone tell me what are the types of prototyping you have learned before? You know what? You need to know altogether 4 types of prototyping. I'm very sure you have learned some during my elicitation, correct or not? What are the 2 types of prototyping I taught you during elicitation? Mock up, very good. One more. Well, not bad. I notice up there also I have some answers. Okay. In evolving, throwaway. Oh, okay. Evolutionary and throwaway. Okay. Now I write evolutionary, throwaway. Correct or not? Can you tell me what is the difference between this? I think you use different name, mock-up or throwaway, is it? No, throwaway and mock-up is the same. Throwaway and mock-up is the same. Evolutionary is your prototype. Okay, you prepare prototype. Of course, you prepare some interfaces with very little navigations and features. Maybe no features or very little features. But when you go and get the feedback from the user during the elicitation, right, you come back and convert slowly to the actual system. You fix it. Whatever feedback given, you fix. At the end, it will become the actual system. So that is evolutionary. That's why it sounds like, slowly it will become the real product. But of course, there are drawbacks, there are advantages of doing it. Throwaway is just for elicitation purpose. So you go and collect the requirement. After you come back, okay, you get all your requirement, then you don't need the prototype anyway. So you can call it as mock-up or throwaway. You understand or not? That is for, sorry, I got no time to go and mute it. Okay, sorry for the background noise. Okay, so throwaway, remember, evolutionary, both also during the elicitation. Now, for validation and verification, I'm going to introduce two more. Very hot topic. This one also on and off I ask in exam because you need to know. Okay, for validation and verification also, it can be done with the help of prototype. We can validate, verify requirement with the use of prototyping. Okay, what are the two types of prototype we use for validation and verification? Okay, one is, before I get into that, I give you an introduction. Okay, prototypes are validation tools, okay, to make requirement real. So sometimes, right, you already collect the requirement, okay, but you want to go back to the same type of customers or client to validate the requirement. When they are not able to tell you the requirement during the elicitation, do you think they are able to validate the requirement for you? Can or not? During your requirement elicitation, they are not able to explain the requirement. They are not very IT oriented, let's say IT savvy. But when you somehow manage to get the requirement using prototyping, so when you are going back to them to validate the requirement, do you think they can validate for you? You will face the same problem. Okay, so you need to use again prototyping to let them validate. You understand or not? So there are two types of prototype that I will introduce to you for the validation purpose. So they allow the users to experience some aspect, okay, of what a system based on requirement would be like. So they can tell you, yes, this is what I want. Yes, exactly, this is how I want the system to be. So they can get experience and they can feedback to you. Okay, so what are the things can be, or what will be validated by the client, whether it is what they want, complete or not, okay, feasible or not, can really do it or not, possible to implement or not, clearly communicated or not. Okay, so now I show you the two types. Okay, yeah, mock-up and proof of concept. Proof to concept. No, not proof to concept, proof of concept. Okay. So mock-up prototyping and proof of or proof to, wait, I double check. Mock-up and the other one is, yeah, it's proof of sorry. Okay, proof of concept. Okay. Mock-up and proof of concept. Okay. So mock-up prototypes exactly the same role as a mock-up prototype for elicitation. So after you develop the system, right, you want the feedback from the user. This is what they want or not. So when they try, they train themselves, they experience, they can tell you, yeah, this is what I want. Oh, this is how I want the document to be generated. Yeah, this is how I want the receipt to be printed. At least they can tell you, okay, this is what they want. So they can validate the requirement to you. Okay, the what do you call that? Mock-up prototype, no big deal. Should be no problem. Okay, so now we're going to go through both of them. This one can come in exam, usually comparison. Compare the two different types of prototype can be used to validate and verify requirement. Okay, so mock-up prototype, also called as horizontal. Okay, why we call mock-up prototype as horizontal? I summarize at the end. Let me explain first. Focus on portion of user interface, same like no, normal what traditional prototype. Okay, just prepare some interfaces with very little navigation, just the surface level. Okay, into all architectural layers or into detail, no need. Don't go into every layer. No features needed. Just some interface with navigation. Let the customers to experience and tell, yeah, this is how I want. So the customers know, okay, when I sign up, I have to fill up the form. When I forget the password, or I need to click on this link. So at least they get the experience and they can let you know, yeah, this is what we want. So it displays the packets of user interface screen, permit some navigation, exactly like how prototype look like. It lets you explore some specific behavior intended system goal and refining the requirements. Okay, so basically that's mockup. Why mockup is called horizontal? Okay, I will explain this shortly because I told you surface level, what surface level. Okay, so that's why it is horizontal. Okay, now let's look at this is example. This is example. Now look at the other one. Sorry. Now the other one is proof of concept. Okay, proof of concept is known as vertical prototype. Okay, sometimes you develop a system, right? You can write the requirement. We all able to write the requirement, but the problem is whether the project is feasible or not. Feasible or not. So even final year project, sometimes students come and tell me some, sometimes they give me some titles, right? Sounds so interesting. Then I always myself, I always ask student, it's not I want to choose the student, I don't do that. I just ask the student to go back, okay, find what are the modules, what make up the system, and then I want you to conduct research in 2 days to find out and roughly tell me how to develop the system, how you're going to come up with a product. I always ask students to do this when they come and approach me. You know what? I don't want them to simply propose a title, but at the end, they are not able to do it. So I don't want them to put their life in risk. So that's why I always ask students when they have some interesting title, very easy to get A, obviously. But if you complete, if you don't even complete, no way to pass, right? So I always ask the student to go and show me that this is possible to be implemented, feasible. This is possible for you to complete. So at least you go and find, is there any existing algorithm that I can use to do this part? Okay, is there any devices needed? Or if I need this device, do I have this in market? So at least go and find out. You understand or not? So that's the study I asked student to do. So that is actually proof of concept. Okay, also known as vertical. Why vertical? Okay, give me 2 minutes, I will explain. Can demonstrate that the requirements are feasible, possible to be implemented. Okay, so now requirements later need to be into a real system one, need to convert to code one. So possible or not, feasible or not. That's the reason why we go for proof of concept. Okay, so it's not only interface, but it is implement a slice, a piece of cake, like okay, a slice. Okay, application functionality from the user interface until the final layer. Okay, all the technical service layers. So you go one, you just take one component, like one feature or one unit, but you try to implement from A to Z for that one unit, make it work completely. So if you take registration, you show me the registration from the interface until the database connection, reading, writing data, validation, everything, all the technical layers, and show me that it works, it can be done. Okay, but this registration is a simple thing. What I'm trying to say is when you come up with a project idea which is very new, very rare, like no any existing reference, so you want to show that it is possible to be implemented. In that sense, you need to show me all the technical layers from the interface until the last layer. Okay, for one piece, only for one component. Okay, it works like a real system, but it just complete one component. Okay, to work because it touches on all levels. Use when you are uncertain whether your proposed architectural approach is feasible or not, can be done or not. Okay, so to optimize the algorithm, evaluate the proposed database schema, confirm the what soundness of cloud solution. These are the examples. Okay, to make the result meaningful, such prototype are conducted by using production tool, obviously. Okay, in the real operating environment, or like production like operating environment or real environment. Okay, so now I show you. Wait, new slide here. Okay, so now let's show you. Okay, now this is a system, right? Why my hand very shaky today? Wait, no eraser here. Hey, there's a clear, right? And I might continue. So there are few layers. So sorry for diagonal layers. Okay, there are few layers. Okay, so this is always UI interface because this is the one interact with the user. Okay, maybe the last one is always model layer. That one connect to the database. In between, got so many technical layer. Depends on different types of system. They have different layers. So when you just cover this horizontal layer, maybe use different one. Okay, when you just cover this horizontal layer, that is the mock-up prototype. That's why it is known as horizontal prototype. But for what proof of concept, you want to show that this idea is feasible. Okay, this you can come up with such a good requirement document, but your client don't have trust on you whether it is possible to be implemented or not. So you come up with one vertical layer, all the layer you touch one component, you complete all the layers. One component you develop all the layers. UI, it's the logic, control, it's model, everything. You complete on one complete layer, okay? Sorry, one complete component with all the layers and show. See, this is possible. It works. Okay, so that is feasibility, to prove the feasibility. So that is vertical layer. Vertical layer. Okay, so that's why we call it as horizontal or vertical. So proof of concept is vertical while mock-up is horizontal. Any question? This one hot question, quite hot. On and off will be there in exam, this one. So any question on prototype? So if prototype, you need to know for validation, there are two types of prototyping, mock-up versus proof of concept. Don't forget. Don't confuse with what elicitation. Elicitation, we have evolutionary, throwaway. Here we have mock-up and proof of concept. So total you learn four different types of prototype for different purposes. Mean mockup to with straight line UI layer. Yeah, mockup is just the UI. You only cover one layer, but you don't cover all the interface, but most of the interface maybe. Okay. Sorry, mean mockup. Do with straight line. Yeah, UI layer. Meaning you cover only one layer. What you don't touch on the other layers. UI and navigation is just one layer. What the outmost layer, the surface layer. You don't go deep into the other layers. But if you want to do the what do you call that? What is the other one? Proof of concept. You need to touch on the other layers, but you don't do for the. If you do all, then whole system is completed. We don't do that for the beginning stage. So we just want to prove, show the feasibility. So we cover one component like one unit function or few unit functions. Okay, we just cover all the layers. Okay, for that particular function and show it is possible to be implemented. This is feasibility. Okay. Sometimes your research need to come with a prototype. That is actually this prototype, feasibility prototype. People can simply research and say, I can, this can be done, that can be done. So when that's why always software engineering program, right? Any university you go, right? There is no way for you to do your final year project without development. No way. Okay, any IT courses, right? If you come up with a project, research based project, you have to come up with a development. Your development is either a complete development or a prototype, and your prototype is always this prototype, the what proof of concept prototype. Okay, so that's the requirement by MQA, our Ministry of Education. Okay, to ensure the quality, they always make sure that software engineering or any IT related courses, right, you must have at least a prototype, a development. Okay, So some students, last time I used to have students come and ask, is it compulsory to develop a system? No way, for IT students to just study and come up with research work, okay, without any technical output. No way. Okay. Okay, you might also ask general question like following during requirement validation, such as this is just for sharing. Does the prototype implement the functionality in the way you expect? What functionality is missing from the prototype? Can you think any possible error conditions? So yeah, validation, any missing validation, any unnecessary function present. Yeah, like this one like extra over specification or sometimes noises, unwanted requirement. Okay, how logical and complete does the navigation seems to you? Are there ways to simplify any of the tasks if you find too complicated? Sorry. And lastly, were you ever unsure of what do you do next? Okay, class. Any question here? So all these are prototype, okay, related slides. Okay, if you have any question, you may ask me now. Okay, now prototype risking. Prototyping risk. Okay, so what are the risks can be caused by prototyping? When we are using too much of prototyping in our requirement engineering, right? There are some risk. Okay, so let me go through the risk. Pressure to release the prototype. You know what? Sometimes when your customers are not really IT savvy, right? They are influenced by the prototype. Sometimes right, prototype you don't have to really use the actual tool to develop. You can nowadays use a lot of freeware to generate the prototype. So whatever you generate, right, is just a prototype. You cannot convert it to real system, meaning it is like just mock up, just what you throw away. Okay, so that type of prototype and generated by tools, right, looks so attractive, sometimes look like because it's just interface, nothing else, right? But then we IT people, we know, but when your customers, right, they get influenced by the prototype, they give you pressure to release the prototype thinking that's the system. That is just prototype generated by tools. That is one risk. Okay, the other one, distraction by details. Work with real looking prototype. User might too focus on the user interface and focus too much on the interface. So they forget about primarily concerned functions or issues on the what do you call that on the requirement stage. So they too into the interface and the prototype. Okay, unrealistic performance expectation. Yeah, you see, now when you develop the UI, right? Clicking on the UI, right? There's nothing, no function, no processing. So obviously, when you click, it will go so fast. You get what I mean, right? Like login, click, straight away show you there's no validation done because there's no function done. But some people who got no IT background, they get what do you call that affected by this kind of fast performance. Then they can what do you call that expect something like this in the real system. That can be a problem for developer. Okay, yeah, investing excessive effort in prototype. This is our team, development team. All the prototype when it is converted to the actual system is okay, but when you don't use it just to collect requirement or just to validate requirement, so all your effort just go waste. So sometimes you waste too much of time on the prototype, so which actually can be spent on the real project processes, right? So that's another risk. Okay. Any question?
Tips.
Sorry? Yeah, anything? Any question? Sorry, yeah, sorry for all the noise or interrupt. Okay, because my throat very bad. So I pause or I mute. Okay, then I come back. Okay. So any question? No question. We continue. Few more slide. One more topic. Okay. So now, I told you, right, I will repeat the validation and verification. So now we're going to continue with the validation and verification again with models. Previously, generally, what is validation, what is verification, or requirement validation, requirement verification. Now we're going to look into model validation, model verification. Okay, model validation. It is necessary to validate the quality of the models developed, okay, during requirement analysis and specification. So there are four types of conceptual models we have created. So now, okay, what is verification? What is validation? I give you 2 minutes. Can you study this? Understand? If you have any question, ask me. What is validation? What is verification? First, I have given you the general explanation. Now I have actually explained for the models. Try, try to understand. Use back whatever I explained just now. What is validation? Compare with the source, right? What is verification? Verification is the format, the structure, the completeness, all this are verification. So model validation, what do you expect? Model verification, what do you expect? Okay, so look at this. Verification determines whether you have drawn the requirement models right. Okay, you have drawn the models right. Your requirement models have desirable properties. Okay, validation. You see the difference, huh? When you read both, right, it can be confusing actually. Requirements models assesses whether you have drawn the right requirement model. You have drawn the requirement model right. So this one checking whether the models are drawn correctly or not. Checking whether the models are drawn correctly or not. This one checking on the drawing the model for the requirement correctly or not. So this one checking the models are correct based on the requirement or not. This one checking whether the models are correct or not. So very obvious verification is checking on the structure and the format of the models, while this one checking on the requirements, okay, that we have presented in the model. So meaning, if here you are what do you call that, you are checking on the features, your model shows the correct features or not, okay, explain the requirements correctly or not. Here you are checking whether the model itself correct or not, whether you have drawn the correct model, whether you have used the correct notation, whether you have done in the correct structure, that is verification. This one, requirement, present the requirement correctly or not. Okay, so verification determine whether the product of some development activities meets the requirement. Okay, validation assesses whether a product satisfy customers need. This is what I told you. So why I say validation, check with the source. Requirement come from where? Like password, you are the one save your password for the first time, correct or not? Then when you log in again, your password that you input now must be same as your resource, your source, which you have already saved first time registration of account. So now comparing this with the source is called validation. Same. Who knows the requirement? Requirement come from whom? Customers, client. So you see whether validation assess whether the product satisfy your customer or not. Okay, so validation always check whether the requirement correct or not. Okay, your customer what they want and what you develop correct or not. That is validation. But verification determines whether the product of some development activities meets its requirement or not. So when you draw the models, right, you draw correctly or not. Okay, when your requirement says, okay, let's say the requirement say user, okay, register. When user register an account, there are few steps. Okay, then it says a few steps. So when you convert this to a model, right, have you shown this correctly? Include, extend, that is actually verification. Okay, meet customers requirement, check with the source is actually validation. Anyone still confused with this part? This is exactly what I explained in the beginning. The same thing now for model. Earlier for requirement, now for model. Any question, class? Any question? No question, we go further. Okay. Okay, now requirement model validation, example use case validation. One of what the primary business objective for the chemical tracking system, reduce chemical purchasing expenses by 25% in the first year. So a use case that aligns with this business requirement requires a chemical. Okay, this use case include a path that permit the user to request a chemical container that already available in the chemical stock room. So it's already available in the chemical stock room. Use case description: the requester specify the desired chemical, okay, to request by desired chemical to request by entering its name, chemical ID number, importing the structure from the chemical drawing tool. The system either offer the requester a container of the chemical from the chemical stockroom or lets the requester order one from a vendor, either a new one or from the chemical stockroom. Okay, so now this is the use case. This is the use case. So now you have the requirement here, right? This is from your client. This is the requirement from client. This is your model. So your model match the requirement or not? The requirement and the model match or not? This is validation. This is validation. Whatever stated here by the client, match with whatever you have drawn here. If yes, it is validation. Because who knows the requirement? Requirement come from whom? Client. So client only gives you the requirement, right? So if you have come up with a model based on the client's requirement or satisfy client's requirement, that is actually validation. Check whether your diagram explain exactly what customer want. That is validation. Okay. Okay, what is verification? Verification, check whether these diagrams are following correct notation, correct, what do you call that, up to the quality, all those other things are considered as verification. One example of check you can do is inter diagram consistency check. For example, okay, yeah, between DFT and use case diagram, two different diagram. Okay, no, this is one. Okay, this one between DFT and ERD diagram, are they consistent? Whatever you have shown in the DFT also mapped in the ERD correctly or not? Or another example in the class diagram and sequence diagram, whatever you shown in the class diagram and whatever you shown in the sequence diagram consistent with each other or not. That is actually verification. That is verification. Okay, I give you 5 minutes to do this, then we discuss. Okay, 5 minutes for you to do. Okay, I give you 5 minutes from now to do. What's the time now? Okay, 5:20. Wow, so long. I lecture. I thought I can finish fast. Okay, never mind. I give you 5 minutes to settle this. Again, then we will cover the remaining slides. Okay. How do you do the verification between here you can do this verification, right, between one diagram, just one diagram, which is known as intra diagram check. Intra means within the same diagram. Inter means between two different diagram. Remember this keyword are always there in our software requirement engineering. Intra consistency, I taught you in the previous chapter. Inter consistency, same thing. Within one diagram is intra. Inter means within or between two diagrams. Between two diagrams. Intra within one diagram. Inter between two diagrams. Okay. So what kind of consistency or what kind of verification can be done in one diagram alone? what kind of consistency or what kind of checking can be done in or between one and more diagrams or more than one diagrams. Okay, so that's what I want to test. Okay, you try first. Okay, this one mainly verification, cannot be validation, remember. Okay, inter diagram or intra diagram, it is verification because you cannot map this with what client's requirement. Okay, when you are checking on the models, okay, what kind of check can be done in one single model, like DFD alone? What kind of check can you do? Who can tell me? You don't have another level of DFD like context diagram. If I give you DFD and context diagram, then you can compare and check. Now I just gave you one DFD diagram. So what can you check in one single diagram? Can you give me a few? How can you check function? If you want to check the function, you need to go and check the requirement from the client. If you check the client's requirement and come back here, it's already validation. Yes, notation. Very good. So you can see whether, okay, you have every flow line got direction or not, got arrow or not, flow in, flow out, correct or not. Okay, is there any process, any two processes not connected? So every between every entity and process or between process and process must have connection, must have flow line. So you check on the flow line. Okay, you see whether every what symbol is used correctly or not. All those things are intra check between one diagram. Like use case lah, easier. I give you use case like exam, and I mark your exam, right? Some of you have used, even though use case so basic diagram, the first diagram you learn for object oriented. So I told you, right, ellipse shape cannot be rectangle for use case. And I told you use case, one function, one use case. You cannot put two functions in one use case. Can you write like this, borrow and return book or borrow and return accessory in one use case? Are they work in the same way? Do they have same steps? No, right? It is two different now, or they are two different functions, right? So how can you put them in one use case? And some of you have even given me what rectangle use case. So you have never thought that you rectangle use case. Use case always ellipse shape. Then I told you how to name the use case. For example, can you write what accessory management? Can you just write fine? Just fine on the use case. Can or not? Just fine. Is it a use case? What is use case? Use case is a function. So just fine sound like a function or not? Cannot. But some of you have written, most of you have written like this, accessory management. What is accessory management? Location tracking. Track location. Pay fine. Calculate check overdue. Calculate fine. Must use the verb followed by the noun. That is use case. That is notation. That is actually verification, model verification. So for one diagram can check all those things. When come to two diagrams like this, now between the two diagrams. So here we check on the notation mostly. Okay, or completeness can. But when come to this two different diagram, we check on consistency. So like sequence diagram, we show, right, okay, for one function from the use case, what are the classes involved? How do the classes interact with each other or objects interact with each other? So who is the actor and how this actor, when performing the function, the objects interact. So I need to check the objects in this diagram are all from the class diagram or not. If I notice any object from this diagram are not found in the class diagram, not consistent, wrong. That is an example. You understand or not? All these are known as verification, not validation. Here we don't check on the requirement, but we are checking on the diagram itself. So that is verification. Clear? DFD and ERD also same. Okay, DFD will have all the entities, right? External entity. All this external entity must be from ERD. Okay, so all your DFD external entities you must somehow have shown in your ERD. So I see here suddenly there's a what administrator, but I don't see administrator in the ERD. There's no one entity called administrator. Then how? Okay, or you call it here as clerk, then here you call it as staff. Wrong. Okay, and this one also another common mistake I notice in the papers that I mark. Even though the question very clearly said that it is what do you call it? It is a clerk. It is a clerk. And then library, not library, what is that? Accessory shop manager, I think. Yeah, clerk and manager. Some of you go and change it to staff. This time I didn't minus mark lah, obviously. But remember, whenever the role is given clearly, don't change it. Just use back. Okay, then you know what? Another funny thing I want to show you. But no worries lah, it's correct, still correct. Okay, so for example, like I said, I told you clerk can do a lot of functions. So this is clerk. So this is clerk. Okay, so let's say clerk can do a few functions. Oh, sorry, my use case look quite, sorry. Okay, let's say clerk can do all this function. Then I said in my question, shop manager can do all the functions that can be done by clerk. Okay, I mentioned all the functions. Okay, what do you call that? Wait, all the function that performed by the clerk can be also performed by the manager, but manager can do extra things because manager is a higher position one. Ayo, it's not moving, Okay, never mind. So let's say if I say so, right? Okay, how do you show the inheritance? So the manager, you should draw the manager somewhere in the or at the bottom. Okay, then you must say that this one inherit from the clerk. So automatically, all these three functions, right? Automatically, this one, and this one can be performed by this guy. This guy also can perform. Why? Because inherited what? This whatever function by him, inherited by him ready. Then whatever he can do extra, you just connect to him now. So this guy can do something extra, means just connect to him extra. So it won't affect him. Okay, this guy can do all this three plus this one. That's the meaning. But I don't know why some student went and did like this. Okay, you did like this in exam, midterm. Okay, so like this is you put a general, you call it as staff. Okay, then you have used this two guys in the scenario. Okay, one is clerk, one is manager. So you call this as clerk and this as the manager. Then you connect all this common function with this one. Okay, all the common function, and then only manager got extra function. Okay, then you have done something like this lah, obviously, like this, and then you put the arrow here. Okay, what's wrong with this now? So clerk inherit from staff. So whatever common function, both of them can do. But he got extra function. So which one is better? Which inherit? This one also correct. This one also correct. Okay, but you have done unnecessary extra work for this. Why this clerk got no extra function here? Okay, only inherit from him. Why not this clerk go and replace him? You understand or not? Why you want to have two people with the same function? Yeah, two different actors with the same function. Why you are wasting? Why not you go and put this guy over here and just this guy inherit, because only he got extra function, just like I did here. But this is not wrong. I cannot give you wrong. Since you have applied the inheritance correctly, you get your marks. But don't waste your time lah. This is wasting of time by creating too many actors. Okay, understand? So this I notice when I mark your midterm. Okay, now continue. Finally, acceptance testing. Okay, customers assess whether a system satisfy its predefined acceptance criteria or not. So basically, when you first slide, you remember I told you, right, the moment you come out with the what do you call that? You come out with the requirements, finalize the requirements. What happened? You will come out with all the acceptance data, test data. Why? Because your testing is always based on the requirement and not based on the code. Okay. Acceptance criteria and hence acceptance testing should evaluate whether all your requirements are satisfied, not all the codes are satisfying the requirement. Okay. So always remember, the moment you prepare the requirements, right, your testing team can work independently. They don't have to wait for the development team to come up with the code. No need. The moment the requirements are ready, you can start preparing your testing. So the moment code is ready, you conduct the testing. You don't have to wait to prepare for testing when the code is ready. No need. Waste of because you know what, your coding and your testing must be independent. They cannot be influencing each other. Your testing team and your coding team also cannot be the same team. Cannot influence each other. Okay. So you must have two independent teams. If you go to big companies like multinational companies, they really practice this. They have different department for different process, like what testing always different from development. But if you work in a small company, cut costs. They will ask you to write the code and they ask you to do the testing. That's not supposed to be. It's not supposed to be that way. Having user device acceptance test is a valuable contributor to effective requirement development. The earlier the acceptance tests are written, the better it is. Okay. So the sooner they can help the team filter out the defects of requirement. So testing team can actually work closely with the requirement engineering team. Okay. Creators of acceptance tests should consider the most commonly performed, most important usage scenario. Okay. And then when deciding how to evaluate the software acceptability. Okay. So basically you need to know, because you know what, now you conduct the testing, right? How do they, at the end of the project, right, your client will conduct the testing. They will involve in the testing. You conduct the testing. Let's say your project team, the development, the testing team conduct the testing. And let's say your client involved. How do they decide, okay, this system can be accepted or the system need to be rejected? Need to go through some improvement. How do they decide? All those things also need to, they need to decide on that based on the requirements. Like, usually high priority requirement must be satisfied, or at least 85% of the requirement must be passed. So, or at least a certain module requirement must be all working fine. So they have to have their own criteria. Okay. Focus on the testing, the normal flows, the use case, and the corresponding exception. Right, normal flow and exception flow. You will learn this very detailed when you take SQAT, software quality assurance and testing course. Every student will take software engineering. Okay, it's a continuous course. So you guys need to take SQAT, software quality assurance and testing. You will learn how to prepare normal flow, exception flow, how to know how many flows are there. You will learn all the graphs, a lot of things for testing. Testing is not as easy as we know now. There are a lot of things about testing. Okay. So you guys need to identify, okay, all the all this information based on the requirement. That's my important thing here. Okay. Okay, now you can see defining acceptance criteria. When do you decide whether the system can be accepted or not as a client? How do you decide whether this system is ready to be accepted or not? So I give you a few criteria. You can just go through quickly. Specific high priority functionality that must be present. So all the high priority requirement must be there in the system. Okay. Essential non-functional criteria or quality metrics that must be satisfied. Important quality requirement must be satisfied. Remaining open issues and defect. There is no more remaining open issue or defect. You can conclude, okay, say there's no very serious, any more serious open issue or defect. So I say this system is ready for acceptance. Okay. Or specific legal, when come to compliance legal, okay, regulatory and contractual conditions are satisfied. Okay. Or supporting transaction infrastructure or other project, okay, requirement, which is nothing to do with product, nothing to do with functions, are also satisfied. Okay, so these are the five main criteria that we always consider when deciding on the acceptance, okay, of the system. Okay, okay, the last part, acceptance criteria. Okay, pro and cons. The value in writing acceptance test is it guides users to think about how the system behave following implementation. So it's actually when you prepare your acceptance criteria, right, it helps you to what do you call that, understand your requirement even better. You can, because you study how the system will behave, so you try to understand it helps in understanding the requirement even better. But the drawback, there is a drawback when you prepare your acceptance criteria, right? The problem with writing only acceptance test is that the requirements exist only in people's mind. By not documenting and comparing alternative views of requirement, user requirement, functional requirement, analysis model, test, you can miss an opportunity to identify errors, inconsistency, and gaps. So this is the drawback. This is the advantage of preparing acceptance criteria. Okay, so when you write the acceptance criteria, okay, it can prevent you from analyzing the rest. Okay, rest of the component in the requirement document. So that is another drawback. Okay. Okay, that's the end of chapter. Okay, before I let you go, any question? Okay, tips for final exam. Come for final class next week Thursday. In DKABA. Okay, I have one more. Okay, since you guys got no question, you're always so kind to me. You don't have question for me, but I'm not as kind as you. So let me ask you a question. Okay, what are the important topics come to your mind when I say chapter 6? What are the important topic comes to your mind? Okay, compare the two prototype. Very good. Okay, you asked for tips, right? Okay, let me recall. What are the important topic? Okay, comparing the two types of prototype. Okay, one is what? Uh, mock up prototype, and the other one is just now I was telling that all layers, which is proof of concept. Yeah, correct. Okay, proof of concept and also mock up prototype. Okay, brain works so slowly. Okay, so proof of concept versus mock-up. Okay, so one is horizontal, one is vertical, one is to test on feasibility, one is test on the to validate the requirement of the clients by producing the UI with very little of you navigation with no function. So just explain and compare equally each of criterions. Okay, okay, that is one. Okay, yeah, inspection and review. So I don't ask you this now. Obviously, I won't ask this. Don't waste your time. But you need to. I cannot say that don't study this. I don't say that. You need to know. In future, for any other course, if you guys are planning to come into teaching like me, then you guys need to know all this very well. Okay, or you are planning to do research, then you also you need to understand all this very clearly. So but I don't ask this in exam, but you need to know the flow, what are the four important activities. But okay, for this inspection and review, yes, what are the techniques can be used? Okay, like one is checklist, right? So what are the types of checklists? Okay, then next, what else? Okay, one is different types. One more important topic no one mentioned. Yes, very good. Validation versus verification. That's very important. Okay, either I can ask requirement validation versus requirement verification. Here, I can ask requirement validation versus requirement verification, or I can ask model validation versus model verification. Okay, and lastly acceptance test. Okay, so if you want to have more what tips on which one to focus more, you come for my final class next week. We will cover chapter 7, and also we will do revision with past year. So please come for the classes. Okay, so I'll try to be there for physical class, no more online. I find it today. I came just now morning, but then I was sitting and checking on the presentation. Right, even that I felt like quite dizzy and like shivering. So I worried to come to lecture all the way like this. Okay, and then standing there. So that's why I thought of having online. So next week I will be back for physical classes, and next week classes are important. Please be there. Okay, you I will teach you how to study and score the exam. So please come for final classes. Okay, last week final week I don't cancel any lecture, so please come for both lectures. Practical class depends on your lecturers, your tutors, sorry. So if your tutor have done with all the what discussion of midterm and already written your marks or whatever, and practical presentation all over, assignment all settled, then final week if they don't want to do what practical class can, because usually the time will be used for make good. It depends on the tutors. Okay, so just check with your tutor, but tutorial always on until the final week. Okay, so please go for all the tutorial classes and revise. Okay, discuss all the tutorials. Okay, make sure do revision. Okay, I think that's all. No further question means we end the class here. See you. Bye bye. See you next week. Okay. Wait, miss, for the presentation we need to wear formal. You cannot refer to the slide phone. Yeah, referring to the slide, right? Your marks will drop.